I wanted to show an example of using a join group. So I wanted to show you what join groups look like or how you could query them. And I've already pre-created these. And so the first part of this is the actual query. There's a view called user join groups. And I see that on my line order table, I've created join groups for order date, part key, and supplier key. And actually, what I did here is I created a comment so you could actually see how I created those. What I did is I actually ran that syntax, and then I repopulated my tables into the column store so that we could take advantage of the encoding. We have to repopulate because we have to be able to sync up the values together. Sorry, it's hard to do this on the
No, it makes perfect sense. Now that we've seen the picture, I think that in order for them to share that common dictionary, once you give me the join group, we can establish the common dictionary, but then we've got to repopulate the tables to make sure they use that common dictionary. Makes sense.
Exactly. And then if you, we'll go ahead and run a query using join groups. And that was our query before. And I don't show you an execution plan because it isn't any different. You can't tell from the execution plan, well, we'll qualify that, but from a normal like DBMSX plan, you can't tell that we use the join group. What all of this here is from one of my the labs that I do. We create a SQL monitor report. So that is a way to tell whether to use the join group. So all that gobbledygook there is would be saved into an HTML file, and I access this. And so what it does is it creates this file here. And this is a SQL monitor, what we call a SQL Monitor active report. It's the easiest way to visualize this. Actually, SQL Developer, the guys, Jeff Smith and company, are working to actually make this available so you don't have to run necessarily this Flash version of it. You'll be able to do this directly in SQL Developer, because if we look at our binoculars here, let's see if I need to go down to pick, for the hash join, if we look at these binoculars, you can click on that, and it'll give you some of the other information that is associated with the join or the operation itself. And notice we have columnar encodings leverage. It's not highlighting on the screen, sorry. But the very last one says columnar encodings leveraged 1. And that means we used a join group as part of the query, and that's how you can tell. There's actually a columnar encodings observed and then the leveraged, because we actually have some other optimizations, and I talked about this, and we have actually 2 blog posts that cover join groups. So if you're interested in some of this information, you can go take a look at those blog posts. The bottom line is that's how you can tell whether you used or leveraged the join group. We're working to try to make that a little simpler to see, but for now, because it actually occurs at the execution level, not at the scan level. I mean, it occurs at the scan level, but it gets reported in the multiple layers of Oracle. We actually don't get this information reported to us until we're into the execution phase, after we've already left database in memory, if you will.
So that's why it shows up. I'll also see it in the elapsed time, though. Hopefully it'll be a little faster.
It'll be a little faster. It's not like orders of magnitude. It's not like the hash join Bloom filter 10x performance improvement. But in most cases, you'll see a performance improvement. It'll typically be in the tens of % improvement rather than the
hundreds
X, your orders of magnitude. But it's still, remember, we're trying to save as much CPU time as we can. And across, again, we're doing this for commonly joined queries. And so across a large workload, this can add up to a significant CPU savings. And again, CPUs are relatively expensive, CPU cycles. And so the more you can save, the more queries you can run, and maybe the less you have to buy. So again, leveraging that, and especially in a mixed workload environment, to be able to run real-time analytics, be able to run analytic queries right on source data in essentially your OLTP system or your mixed workload system.
Is it also true that I might be able to save a bit of memory and perhaps prevent a big, a join between 2 big tables spilling to disk if I leverage this, given the fact that the values I'm working on are those symbols rather than the actual values?
Sure, yeah. We should save memory in the PGA because we don't have to access all of that information translated basically, right? So
Right.
we don't have to compare the full value of the full value. We can actually just work on the dictionary symbol. Yeah, so we should see less PGA usage in addition to that. Although I don't have any concrete examples of how that would work. That's pretty data usage dependent. But,
of course, yeah. But ideally, it would help a little in that way. And as you said, then you put it in a mixed workload environment where the system's already very busy in terms of CPU and memory, and you might just be able to get some more extra mileage out of those CPUs, let's say.
Exactly.